Hello everyone, welcome to my lecture series on numerical methods, and today we'll talk about why we'll study numerical methods. So I'll give you some examples. So why we require, because there are lots of applications of numerical methods. So let us suppose consider an equation like fx equal to 0. So it can be polynomial equation, and it can be transcendental equation. It can be transcendental. So I'll give you the example what type of equation we call polynomial equation. Like for example, if we have x square plus 5x plus 1 equal to 0, or for example x cube minus 3x square plus x minus 1 equal to 0. So this type of equation are called polynomial equations. And transcendental equation, so a equation which contain transcendental function is known as transcendental equation. So transcendental function are like sin x, cos x, e to the power x. So if the equation contain like this, x sin x plus suppose cos x equal to 0. So this type of equation are called transcendental equation. Now suppose if we like to find what are the roots of this equation. So if you want to find what are the roots of this equation, we do not have any analytical methods to find the roots of this transcendental equation. But we have method for like x square plus 5x plus 1 equal to 0 till degree 4 polynomial, we have analytical approach to find the roots. But after degree 4, if it is degree is more than 4, or if it is transcendental equation, if you like to find the solution of this equation, then we do not have any analytical method. So we have to solve by using numerical approach to get some approximate value so that fx will become 0. Now I'll tell you geometrically what is the meaning of roots. So let us suppose this is the coordinate axis, x axis, y axis, origin, and suppose this is the function. Let's suppose this is fx, and let's suppose consider one interval a comma b. So root means what? The point at which the function cuts the x-axis. This point is known as roots. So we have to find this root, approximate value of the root, by using numerical methods. We have different numerical techniques to find the roots of this equation. Like we have bisection method, we have Newton-Raphson method, we have regular Falsi method, how to find the roots of this type of equation. So I'll tell you later, but first of all let's try to understand. Suppose for example for this function over here, over this interval, the function has only one root. So a function can have one roots, two roots. Like if this equation we know how to find its roots, so it has two roots, it has three roots. So roots can be finite, roots can be infinitely many also. Like for example, if we consider this equation like sin x equal to 0. So this is a transcendental equation, So it has how many solution? We know its general solution. We can write x equal to in this form n pi, where n is integer. So there are infinitely many roots. So we know the graph of the sin x function. So what are the roots if we try to draw its graph? So if we plot this function sin x, so you know sin 0 is 0. So it's a periodic function with period twice pi. So this side also we can extend the function like this. So this is like 0, pi, this is 2 pi, like this. It's minus pi. So there are infinitely many roots of this equation sin x, because this function cuts at infinitely many points. On the x-axis there are infinitely many points where the value of the function is 0. So function can have infinitely many roots. It can have finite roots, but our aim how to find these roots. If there is no analytical approach, we have analytical methods to find this root for sin x equal to 0. But if we take like this x sin x plus cos x equal to 0, we cannot solve this way. We have to find, or there are many others type of like x square. If we write x square sin x plus cos x equal to 0, or if we consider like e to the power x minus x plus sin x square equal to 0, this type of equation are also known as nonlinear equation, right? So this equation we cannot solve analytically, we have to solve numerically. So let us discuss one numerical methods how to solve by using bisection method. So but before this I will talk about little what is known as intermediate value theorems. Intermediate value theorem. So let us consider this equation fx equal to 0. So what I said, that what is known as intermediate value theorem. So this is very important, we should know. So intermediate value theorem. So let us consider the function fx is continuous. Let us consider fx is continuous in the interval ab, and suppose the function value at a and function value at b, if this less than 0, then by intermediate value theorem we can say there must exist at least one real root between a and b. So from this graph it's very easily we can verify this theorem. So if suppose this is the function, at a the value of the function we know it is fa, at b the value of the function is b, fb. So this is our fa here, over here this is we have the value fb. So it's very easy to verify that if fa into fb less than 0, if their product is less than 0, then there must exist one real root. So obviously the function must intersect. If one side is positive and another side is negative, so obviously the function must intersect the x-axis at some point, and that point is the root. This point is called root. So we have to find this root. So the first step of bisection method, we have to find the interval in which root lies. So here the interval ab, so where this function, this equation has one root. So first step we have to apply, we have to use intermediate value theorems to get the interval where the root lies.